Welcome back, everybody. In this video, we're continuing our look at building up fractions. As a reminder, the reason why we would do this is to help us with things like adding fractions later and also comparing fractions to decide whether which of two fractions may be larger. So I want to get started with an example. We're going to write a fraction that is equivalent to 2/3, but has denominator first 12, then 15, then 21. So if we want our fraction to be equivalent to 2/3, it of course has to have the same value. And we're going to, in the first case, change it so that it has a denominator of 12. So as we've seen, according to the fundamental property of fractions, if we're going to multiply the denominator of the fraction by a number like 4, which is what we need in this case, we had better multiply the numerator by the same value. So 2 times 4 will be 8 for this. So then 8/12 is our fraction equivalent to 2/3, but having a different denominator. All right, next we have 2/3. We want to change that into 15ths. So we can say, okay, well, 3 divides into 15 5 times. And so we'll be multiplying 2 times 5 also. And that will give us, of course, 10 in the numerator. And so our final answer is going to be 10/15. For the last one, we want our fraction to have denominator 21. So 2/3, 8 into 21st. How many times does 3 go into 21? It goes 7 times, as you said. So 2 times 7 is 14, and this will make 14 21st. So there are 3 fractions that are equivalent to 2/3, having all different denominators. As we saw when we were simplifying fractions, there was one answer, right? You simplify the fraction as much as you can, which you should, and you get one answer. Here, we are writing a fraction with 3 different denominators. So how do you know which one you should do? Well, at this stage, part of it is you're just told which one to do, like in this example we just did. Going forward, you're going to know based on a procedure you haven't necessarily learned yet. In adding fractions, you'll need to know how to create a new denominator, as it'll turn out, but you'll learn more about that when we do addition of fractions. But the point is that you'll know at that time. And the short answer is how you're going to know what the denominator that you need is dictated by what it is that you're trying to do with that number. Okay, so our next task is to look at how you can compare fractions by doing this. And to do this, we'll see this with a little story problem. So suppose that you're in a class that takes quizzes, and you took one quiz and you got a 17 out of 20, and you took another quiz and you got a 21 out of 25. And so a natural question would be, well, on which quiz did I do better? And so let's think about that for a few minutes. So on the first one, you got 17 out of 20. And then in the second one, you got 21 out of 25. In the first case, you only missed 3, which sounds pretty good. In the second case, you missed 4, which doesn't sound as good. But on the first one, you scored lower. You only scored 17. In the second one, you scored 21. So your score is higher on the second one, but the second one was worth more points. So it's kind of hard to compare. And one thing we could do would be to turn this into a decimal or a percent, but that's not what we're doing today. So our other option would be to change this and make it, what if the 2 quizzes were out of the same amount of points? And so that's what we'll do. So taking a look at 20 and 25, we'll think about what would be a number that both 20 and 25 will divide into. So after some thought, it should occur to you that both 20 and 25 will divide into 100. So we're going to build up both of these fractions so that they have a denominator of 100. And if they both have a denominator of 100, then we can compare the 2 numerators. So how many times does 20 go into 100? 20 goes into 100 5 times. If we multiply 17 times 5, got to multiply the numerator and denominator by the same thing, right? 17 times 5 will be 85. For the second fraction, 25 goes into 100 4 times. Multiply the numerator by the same thing. 21 times 4 will be 84. So what does this mean? If we turn the two fractions into equivalent fractions, their values haven't changed, and we're acting basically as if the two quizzes were out of 100 points, even though they weren't. But this makes it easier to compare the two. The first one, you got an 85 out of 100, essentially, and that is better than an 84 out of 100, which is essentially your score for the second quiz. So the point of the story here is that turning the two fractions so that they have the same denominator makes it easier to compare their values. And that's one other application of building up fractions. Okay, let's see a couple more examples. All right, so here we have 3/7 and 11/35. I'm going to replace the question mark by either less than or greater than in order to make a true statement. All right, so we want to take a look at 3/7, and we're going to say, well, I need to compare that against 11/35. So what would be a good new denominator? Well, I'm sure that you noticed that 7 divides into 35. So let's build up the 3/7 into 35. So we need to make it have a denominator of 35. So 7 times 5 will be 35. And 3 times 5 will be 15. So 3/7 is like 15/35. And then 11/35 is 11/35. 15/35 is bigger. So we want a greater than sign in there. 3/7, which is the same as 15/35, is bigger than 11/35. Okay, let's try that again with 3/4 and 5/6. So for 3/4 and 5/6, take a look at the two denominators, which are 4 and 6. We want to find a number that both 4 and 6 divide into, and a good choice would be 12. That's what's called the least common multiple of the two numbers. Again, that's something else we'll go into greater detail at a later date. So we need to change 3/4 and 5/6 so that they're both 12ths. Okay, so 3/4, we want to turn that into 12ths. So we'll have 4 times 3 is 12. 3 times 3 is 9. 3/4 is the same as 9/12. 5/6, we need to turn that into 12ths. We'll multiply the numerator and denominator by 2. So 5 times 2 is 10. That's 10/12. So we have 9/12. That's our 3/4. And 10/12. That is our 5/6. 9/12 is less than 10/12. So 3/4 is less than 5/6. And once again, how we did this was by changing the two fractions so that we have an equivalent fraction or two equivalent fractions having the same denominator. All right, so we want to finish with some examples. The next two slides are basically just more examples. This one is about the building up process, and the second part is about building up for comparison. So if you're comfortable from here, then you can leave. Otherwise, let's continue and take a look at some examples. All right, so here, first of all, we want to express 2, just that whole number 2, as an equivalent fraction having a denominator of 2. So I'm going to put these down here. That's number 33. Okay, so 2 is the same as 2/1, and we want it to be have a denominator of 2. And I know you're not just going to write a 1 on the top here, right? We're not just going to flip the fraction over. It doesn't work like that. So instead, we'll look and say, okay, well, I know I'm going to multiply 1 by 2 to give 2. We'll multiply the numerator also by 2, so we'll have 4 divided by 2. So we should have 4 halves for number 33. Okay, let's try 34 next. We're going to express 2 as an equivalent fraction, but this time having a denominator of 8. So 2 over 1, we'll need to make that so that it has a denominator of 8. And so here we'll multiply both the numerator and denominator by 4. So, or by 8 rather. So 1 times 8 is 8. 2 times 8 is going to be 16. So we will have 16 eighths for number 34. Okay, let's try 35 next. We want 18 nineteenths to have a denominator of 95. And that sounds kind of hard maybe at first, but it won't be so bad, I think. So 19 and 95, you're going to want to divide 95 by 19. It's going to turn out to be 5. If you think about nickels, how many nickels there are in a dollar, there's 20 nickels in a dollar, and that makes 95 cents for 19 of them. So 5. All right. Okay, and then 18 times 5 is going to be 90. All right, so 90 95ths is our final answer for 35. Okay, and then our last one, 36. 17 22nds. We wanted to make that have a denominator of 44. So here it should look like we need to double the numerator and denominator, and in fact, we will. So if we're multiplying the numerator and denominator by 2, we should have a 34 in the top. So that last one will be 34 over 44. Okay. So using those 4 basically as a model, let's try next the column on the right. So pause the video here, try these 4, and then I'll restart the video and see how you did. Okay, let's take a look. So for this first one, number 37, we have 1/3. We need to change that into 24ths. We're going to be multiplying by 8. 3 times 8 is 24. 1 times 8 will be 8. So we have 8 24ths for our final answer. Next, we have 15 19ths. 15 19ths, we saw that 19 goes into 95 5 times. And so 15 times 5 will be 75. 75 95s, or 95ths, is our final answer. Next, we have 16 over 1. We need to turn that into fourths. We're going to be multiplying by 4. In the top and bottom, 16 times 4 is 64. So we'll have 64 fourths. Okay, last one, we want to make 5, a whole number, into a fraction with denominator 2. And so you're going to recognize that we should end up with 10 halves for that. Okay, so that takes us to the end of these couple examples on building up fractions. And then our next set of examples, we're going to focus on comparing fractions. So here, each of these statements is paired. So we have one less than and one greater than version for each. And so we're going to try these and decide which one is the true. So these first ones involve some negatives. So I'm going to hold off on those two, and we'll do number 123 first. Okay, so we're comparing 6/7 and 7/3. So 6/7 and 7/3. So we want to think about what would be a good new denominator for both of those fractions. The smallest number that both fractions denominators divide into is 21. So 7 and 3 will build up both of those so that our denominators are 21. Okay, so 7 divides into 21 3 times. 6 times 3 is 18. So our first fraction is 18/21. For 7/3, we're multiplying the numerator and denominator by 7. So we should have 49/21. Okay, this one was actually pretty much of a dumb question, and I'll tell you why here in a second. I worked us harder than we needed to, but in any case, we're finished there. The 6/7 is smaller. So that's the true one. So why did I say that was a dumb question and I worked us too hard and all that? If you think about it, 6/7 is less than 1. Right? It's a proper fraction, and 7/3 is an improper fraction. It's more than 1. Any fraction that's less than 1 has got to be smaller than any fraction that is bigger than 1. So I didn't need to go at that too hard on that. All right, so that was a bit of a letdown. So let's do one that is a little more fun than that. Let's try 1/24 and then a -1, and then we'll be done. Okay, so 1/24, we're comparing 1/2 and 2/7. A number, nice small number that has 2 and 7 as factors would be 14. 1/2 turned into a fraction with denominator 14, that would be 7/14. Right? 7/14 should look like a half to you. And then 2/7, if we change that into a fraction with denominator 14, we're multiplying the numerator and denominator by 2. And so we should end up with 4/14. So 7/14 versus 4/14. The 4/14 is smaller out of the two. And so the 1/2, the 7/14 is bigger. So I'm marking the true statement here. 1/2 here is bigger than 2/7. All right, so let's try one of the ones that is negative. Okay, 1/25, I'm going to skip 1/25 because again, this one is going to be one that is should be easier, and that's because 9/4 is improper and 2/3 is proper. So it should be a little easier to figure out the answer on that. Let me see if we have, okay, 1/22 is good because at least they're both proper fractions. So let's try 1/22. 1/22 is interesting because the two fractions are negative. We have -1/7 and -8/9 we are comparing. So disregarding for the moment the fact that they're negative, we need a new denominator for both of those. So a number that both 7 and 9 divide into will be 63. So we're going to build up both of these fractions so that they have denominators of 63. And so 7 times 9, 63. And then -1 times 9 is going to be -9. Our first fraction, -9/63. That's the same as -1/7. 9 goes into 63 7 times. -8 times 7 is -56. -56/63 versus -9/63. So -9/63 is bigger than -56/63. -1/7 is larger. This is 1/22. -1/7 is larger than -8/9. Okay, all right, so that takes us to the end of the examples I wanted to do on this comparisons, and also to the end of this video. So let me know if you have any questions and continue practicing with this topic, and have a good day.